25. Okay, so solving exponential functions. You've already learned how to do many of these, so we're going to start by reviewing 1 through 4. And as I go through this, I want you to rate yourself. So after we go through each problem, you're going to rate yourself on your understanding. A 4 means I can explain this to somebody else within your group. A 3 means I understand it, but I don't know it well enough to explain it to somebody. A 2 needs I need more practice, and a 1 needs I need individual help, I'm lost. So here we go. We are going to start with number 1. Rate yourself after you go through it. If you feel comfortable, you may work at the same pace that I do. If not, you may follow along with me. Only 1 through 4 at this time. Okay, we have the same base, so the bases gets canceled out. I bring down the exponents. 3x equals negative x minus 2. Adding x to the opposite side. 4x equals negative 2, dividing. And then simplifying this fraction to equal x equals exactly negative 1/2. So in this little box, if you feel like, yes, I could explain this problem to somebody, you're going to put a 4. If you feel like you understand it, but you couldn't explain it, you don't have that level of understanding, put a 3, and so on. Number 2, I need to determine what base should I use to get numbers that are equivalent to 434 and 1 over 49. And it's going to be 7. So 7 to the third is 343. And 7 to the negative 2 is 1 over 49. Okay, we have the bases the same. I can cancel out the bases and now distribute by multiplying. Negative 3x equals positive 6x. And I'm going to choose to move the 3 to the opposite side, so it cancels out on the left-hand side, leaving nothing. 9x is equal to 0. Divide by 9, and 0 divided by any number is 0. Again, we have an exact answer of x equals 0. Not an estimation. You didn't need to use logs to solve an exact answer. Rate yourself on a scale again from 1 to 4. Number 3, I'm going to first analyze it. 27, 81, and 27. I need to rewrite these numbers, keeping the same value but having identical bases. So 3 to the third, 3 to the fourth, and 3 to the third. X, negative 3x, and then just 3 squared. So the bases are all the same. But realize when you have the same base and you're multiplying, you keep the base and you add the exponents. 3x plus negative 12x. 3x and negative 12x is negative 9x. Bases are the same. Now we cancel them out. And we have negative 9x equals x. I'm going to add 9x to the opposite side. And I get 0 equals 10x. Divide by 10. Divide by 10. And I have x equals 0. Did anybody else get that answer of x equals 0? I thought I may have got a different answer in previous hours. Does anybody see any flaws in my work? Yes?
Wasn't for the equals 3 to the cubed, how did you get it to 3x? 3 to the x?
How did I get this part?
No, the next part.
This part? This over here?
No, this back. It went from
Oh, that should have been 3 to the third, right?
Yeah, that's why.
Maybe that's where my mistake is. That's where my mistake is. I was like, I didn't get this in past hours. Thank you, Diego. So I should have continued and put a 3 to the third here, right?
Yes.
So if I put a line, if I put this over the top, at this point I have 3 to the negative 9x equals 3 to the third. Now I can cancel out the bases, and I have negative 9x equals 3. Divide by negative 9. Reduce this fraction to get a negative 1/3. That looks better. Exact answer. Thank you, Diego. Number 4. You can do number 4 because it gives you an exact answer without even using a graphing calculator. So the way I look at it is this. Okay, I need to turn a 6 into a 2/16. Forget about it being a fraction and being in the denominator. 6 raised to what power gives you 2/16? 3, but since it's on the bottom, it's at a different level, it's going to be a
Negative 3.
-3. Again, rate yourself on a 1 through 4 in examples 1, 2, 3, and 4. The first 4 problems all give you exact answers. There's no rounding. When you look at this problem, what is the exact answer? Well, here's the thing. The exact answer is actually log base 4 of 11, because otherwise we have to estimate it. And if you forgot, please write this down. This is a change of base problem. And change of base means we plug it into the calculator like this. Log base 11, it's always the back number. We don't care if it's larger or smaller. Log of 11, enter, divided by log of 4, enter. And then I'm going to round that. So log 11, enter, divided by log of 4, enter. And if I round to the nearest, hundredth, this would be approximately 1.73. So yes, there is an answer here, but it's irrational. It's an ugly decimal. So if they said, what is the exact? This would be the exact. The estimated would be this answer. Exact and estimated. Okay, come down below. Now, I've had one person in 3 classes, one person come up with 3 different ways to do this. Nobody's come up with 4. There are 4 different ways that you know to solve this. Any group of 2 that can come up with 4 ways in 2 minutes will have soda in class tomorrow. Okay, you ready? Work with your partner and only your partner. What are 4 different ways to solve this? 4 unique ways. Both you and your partner work together. Go. Get a timer?
What do we add then?
Well, I know one.
We add the 2.
No, I have one. You don't have to come up with the answer. You have to come up with 5. Well, I know one of them. We could also, I guess, we could like turn it over here and instead of like being it's like turn it into the same base.
Giselle, I sent her an email, so we'll see if she responds, okay? If not, we'll call her at the end. Yeah, just so that we'll call her at the very end when people are leaving.
So the second way, I guess, we could just like plug into the calculator and put 5.
1 minute remaining. Well, let's see if anybody can even get 3 in this class. Does anybody have 1? At least 1. Hands up high. Hands up high if you have 2. Does anybody have 3? Anna thinks she has 3. Anna, can you share with me just one way?
You do like a normal, like you solve it, like you add 2 to the other side.
Okay, so I'm just going to say, here's our first method. We add 2 to the other side.
And then since it's 5x, you do it, you do 125 to the 1/3 power in the calculator.
That's not actually mathematically correct. But what you could do is, your math skills at this point, you know that 5 to what power is 125? 3. So by guess or check, one answer could be 3. How many, when you got to this point, already knew the answer is 3? Hands up high. By the way, that's an exact answer. Who has another method?
I'm not sure.
Okay, go ahead, Diego.
I'm not sure if it's right, but I subtracted 123 on one side and made it so that way it's 5 to the x minus 125 is equal to 0.
Okay, then what did you do?
And then I took the log base of 5 for the entire problem.
Really close. So we're going to go back to this, Diego. You're kind of on the right track, kind of. So I'm going to add it to the opposite side to get 125. And now, Diego, I'm going to do log base 5 because it has to be just one thing on each side.
Okay.
So log base 5 on both sides, because whatever you do to the left, you must do to the right to keep it balanced. Now this cancels. We bring down the x. The log of 125, please can everybody plug that into your calculator? It's going to give you an exact answer. Log of 125, enter, divided by log of 5, enter. Did you get an answer of 3 again? Does anybody want me to repeat that steps? This will be the method we focus on today. There's 2 more methods. So after you add 2 to the opposite side, we come up with 125. We add 2 over here, we come up with with 125. How can I rewrite 125 to have the same value but be in a different form? 5 to the third. Do we have the same base?
Yes.
Cancel, x equals 3, done. What'd you say? The first one was just like guess and check. Just guess and check, yep. Now the fourth one is a graphing calculator. Can everybody do second plus 712? I'm going to say that this is my first equation. So y sub 1 is 5 to the x minus 2. Now most people do not plug this into the calculator correctly. So let's talk about that. Second plus 712. Go to y equals. We're going to use parentheses. So parentheses 5 caret key x. And then behind it was a subtract 2, correct? Then go to the second one and you're going to plug in which number? 125, is he right? Or is it 123? 123. Now remember, this is a horizontal line. So all the way up at 123 will be a horizontal line. So let's go to Windows. And we need to go up past 123. So let's try 130. Then hit graph. The left-hand side will be an exponential equation that's been shifted down 2 units. The right-hand side represents a horizontal line. Find out where they intersect. Please use the intersecting function on the calculator. So this would be a good natural question. People are like, well, I get an answer, but how do I know if the answer is 3 or if the answer is 123? And this original problem, what was the variable? So what is the x answer?
3.
Done. So you come to the AZ Merit ACT or something like that, and you're like, I don't know how to do this. What can you always do? Graph it and find out where they intersect. All right, we're going to go down right now to the bottom. And I should be able to go through these pretty quickly. We're going to go back to what Diego said. This builds upon your understanding of finding inverses. So if I want to eliminate the 9, and so I can bring down the x, I'm going to do the log base 9 on both sides. Whatever you do to the left, you must do to the right. Then I'm going to write down what already existed. So there already was a 9 raised to the x and a 20. On the left-hand side, the log base 9 and 9 cancel, and you bring down the x. Now, what's different about this problem compared to the problem up above? What was the answer for each one of these? 3 every single time, right? Just different ways to solve it. How do you know that I'm not going to get an exact answer here? Can you raise 9? Do you know which number you can take 9 to and you get 20? No, there's a number, but it's ugly. So if they say what is the exact answer, this is the exact answer. You do want to have this down. If a question says what is exact, this is exact. If a question says what is the estimated, that's when you plug it into your calculator. Log of 20, go ahead and you're done, divided by log of 9. So it is approximately, if we round it to the nearest hundredth, 1.36. Exact and estimated. Example number 7. So I see 2 letters here. Which one represents a number? Which one is a variable? E is a number. Good. It's Euler's number. So it's approximately 2.71, something like that. So if you want to get rid of E, we'll do the same. So log base E on both sides. Then I write down what was already there. On the left-hand side, the log base e and the e cancel, and I bring down the x. Now, there's nothing wrong with this, but there's another form that I'd like you to recognize. Diego, what is equivalent to log base e?
Natural log.
Natural log, good. So ln of 56, these are equivalent. If they said what is the exact answer, you're going to want to write one of these. Please look in your graphing calculator and find the ln button. It's below the log. Hit ln of 56, and we're going to round to the nearest hundredth. So approximately 4.03. Please make sure to go back right now and rate your level of understanding from a 1 to a 4 on examples 6 and 7. Coming to examples 8, 9, and 10. Here we go. So this goes back to a rule that I hope you remembered. If not, we will review it together. So my first step is going to be to add 3 to the opposite side. Negative 2 plus 3 is 1. Before I go any further, Ulysses, you can take any number, and if you raise it to this specific number, it will always equal 1. What is that specific number? 0. So if you get to this and you remember, you can just write x equals 0. If not, let's go through the process. Log base 4 and log base 4. Write down what was already there. Left-hand side, they cancel. I bring down the x. And then plug it into your calculator. So log of 1 entered divided by log of 4. As a reminder, misconception is not to plug in what's bigger or what's smaller. It's always log of the back number entered divided by log of the base. So can you guys check for me? Do you still get an answer of 0?
Yes.
Okay, it's an exact answer. Unlike these two, which required logs in order to solve, problem 6 and problem 7 required logs to solve. This is an exact answer. There's no estimation. Let's go on to the next one. Example number 9. I'm going to start by adding 2 to the opposite side. Then dividing by 3. And now you can stop. Put your pencil or pen down. Turn to your partner. Don't tell me, but with your partner, I want you to say, what is this answer? 15 seconds, go. So 5 raised the x. You can get very large numbers, you can get very small numbers, but you will never get a negative, no real solution. And just so you can see, if you plug that in, it would look like this. So log of negative 11, it's already going to share with me. It doesn't work. It's going to say quit, okay? No real solution if you tried to plug it in. Go down to number 10. First, I'm going to subtract 3 from both sides. Then divide by negative 2. Now I want you to decide, does this problem require a log, or can we get an exact answer without a log? So don't do any more work, decide with your partner. Does this problem require a log to solve, or can we get an exact answer without a log? Go ahead, talk to your partner. Can you think of a number that you raise 7 to and you end up with 15? And if people are like, I'm not really sure. Well, 7 to the first is 7. 7 to the second is 49. So there's a number, but it's not pretty. It's irrational. So we need logs. So let's do log of 7 on both sides. The logs and the 7 cancel. I'm going to come over here and I have x plus 2 equals log base 7 of 15. Now I still want to isolate that x. So to isolate the x, I need to subtract 2. Now there's a little bit of confusion here because I just want you to understand that this subtracting 2 has nothing to do with the log base 7 of 15. So you don't subtract 2 from 15. It's this answer and then subtract 2. So if they said what is the exact answer, this would be the exact answer. Now let's get the estimated answer. Grab your calculator, please. Do log of 15, enter, divided by log of 7, enter. Okay, leave it on your calculator. Now subtract 2 from it, and we'll estimate as our final step. So if we estimate and round to the nearest hundredth, it would be approximately negative 0.61. Okay, take time right now to look at 8, 9, 10, please, and I want you to judge yourself on a level of understanding, 1 through 4. All right, next up, with your partner, and this is a tougher question than you think. Explain in your own words, when are logarithms required to solve an exponential problem? Explain. So I'll give you an example. Look at this real quick. Do I need a logarithm to solve that? Do I need a logarithm to solve that?
Yes.
Why? In your own words, or get help from your partner, and I want you to articulate your thoughts with this question. Begin.
I think we would use the logarithm when it's like, it's not an exact answer, but when it's too big, it's too big. The
10 minutes ago. Daniel, can you share with me what you believe the answer is?
That's why when it's not exact, when it's not like a whole.
When you cannot simplify to the same base, that's a great way of thinking of it. So can we simplify to the same base here, guys? Yeah. Okay. Can we simplify to the same base here? No, that's a great way of thinking, Daniel. When you can't simplify to the same base, then you need to use logarithms. Nobody had explained it as simple as that, Daniel, in previous hours. Nice job. Okay, we're going to create one equation in which you do not need logarithms to solve. So here's my equation. You may not use this one. Please create your own unique equation for the next problem that does not require logarithms to solve. You have 15 seconds, go. When you're done, show your problem to your partner. Then go down to the next one. Let's create an equation in which you need logarithms to solve. We're going to start off class tomorrow with this problem about a licha. It's a type of Ethiopian stew. But before that, we're going to do this problem. So find some place on your paper. I'm going to give you right now 2 minutes working with your partner to try to achieve this answer. Ready, get set, go. Fernanda, what do you think is the first step? Do a little bit louder for me, what? Thank you. Now the next step is where many people got confused. Somebody who's not been called on, let's go with Servanda. What do you think is the next step? It would, but there's something that's hiding there in front. Well, actually it's like a -1. It's a -1 being multiplied. So let's divide by -1. Can you shut the door for me, please, Pedro? Okay, now continue solving, please.